So we don't have like a measure of accuracy that we can apply to give us a sort of a more definitive result. And I guess the final thing I'd talk about, or I'd mention, is, I find that topic modeling has been very useful in a range of different applications, like I said, from social media to political speeches. But it only reflects the structure of the data you've got. It's only as good as the data that you've got. And it's best used as an exploratory tool with a human expert who can kind of understand the results. Using it blindly and kind of making inferences based on the words that you see without really understanding the text, can cause problems. So thanks very much for your attention. Just to say, like I said, all of this material is on this GitHub link here. There's much more detail in the IPython notebooks. There's also the sample data set as well. If you have any questions about the material, obviously feel free to ask me now, but feel free to email me or ask me on Twitter as well. That's no problem at all. So thank you very much for your time.
So does anybody have any questions? Okay, I'm going to go over here first and then I'll pop over to you.
Well, firstly, thank you very much for the talk. It was very interesting. I was just wondering, is there anything to be gained by, for example, when you're breaking the text into words, that you kind of measure them as with regard to the grammatical structure? Like, for example, does Donald Trump occur as subject or an object in the sentence and so on, and then treat it slightly differently?
Yeah, so I guess the standard topic modeling approaches tend to treat the structure of the text quite naively. In the simplest bag of words approach, you're completely losing that kind of structure. Using sort of more complex grammatical interpretations of the text is less common. I mean, people do things like entity extraction, noun phrase detection, and use those as potential features. But the type of subject-object relation or something like that, that typically isn't captured by a topic model. But there are simpler NLP things to produce richer features that people do, like I said, entity extraction.
All right, and thank you very much for the talk. I'm just wondering, first of all, the non-negative part, does it refer to the term document matrix, or is it a covariance matrix?
Yes, I probably should have mentioned that. So NMF, the constraint, as the name suggests, is that it only operates on a non-negative matrix. So in this case, the document term matrix is always going to be non-negative. The lowest possible value is 0. So in that case, it works in that case. But NMF is always constrained, or at least the standard variations are constrained to only work on those types of matrices. So that's where non-negative comes from.
Yeah, and so I also understand there is latency mapping analysis, which is practically like a principal component analysis on term document matrix. So I wonder, like, why we call it non-negative matrix decomposition? How does it differ from?
Yeah, so LSA and LSI that sort of predate NMF were widely used again for kind of, partly used for trying to extract topics from text. The main difference with LSI or LSA being based on SVD was that the values and the resulting factors were non-interpretable. In other words, you could get negative values. So one of the nice things about NMF is that the W and H can be viewed as kind of as the parts of the overall matrix, and you can kind of say, these terms to this level or to this degree, and these documents to this degree make up this topic. Whereas with LSA, because the values are potentially negative, it's not clear how you would interpret a negative weight for a document, for example.
And all right, thank you very much. You didn't know that. And the last quick question. So for probabilistic methods, for example, LBA, sometimes you can adapt them to, say, implement supervised learning. But do you see like the matrix factorization based method can also incorporate supervised learning in some way?
Yeah. So there's quite a bit of work over the last couple of years on semi-supervised NMF. So in the context of topic modeling, the idea might be that you have a very small number of maybe documents or terms that you provide as examples. It's not like a full training set, but it's a limited amount of supervision. But having a limited amount of supervision can often, make a reasonably big difference. So yeah, people have looked at that, and as long as you have an expert who's willing to give you that supervision, it's a good way to go. Yeah.
Oh, yeah. Thank you very much.
So I think we have time for one more question. Anybody have another question? Yeah?
So thank you very much for the talk, it was great. I'd be interested in, can you compare the output from something like the LDA versus NMF in this case? I've not come across NMF before, but the topic coherence and maybe even how the topics and service would end up seeming different with both techniques on the same corpus.
Yeah, you can. Yeah. So although the weights that are produced by LDA are probabilistic, the weights that are produced by NMF are non-probabilistic. Once you start representing things in terms of rankings, you can compare rankings. So coherence is fundamentally based on the rankings of terms. The approach that I showed there works equally well on LDA and NMF. The results that we've seen on the corporate that we've looked at generally suggested that NMF tended to be better than LDA, particularly in cases where there were more niche topics, smaller topics. LDA tended to be better where there were kind of larger, broader topics. They're both useful approaches. Like I said, for me, the scalability of NMF is pretty useful.
Brilliant. So if we could thank our speakers again. Amazing talk. And also a massive thank you to Workday for the wonderful facilities. And if anyone would like to join us afterwards, we're heading to Dice Bar. Yeah. So just follow myself. I'll be going over there anyway. And otherwise, I'm going to post details of our next meetup to the meetup page within the next week. So keep an eye out. Thanks a million. Thank you, everyone.
A lot of weight on my shoulders.
Like, the test is very long, like, there's always to be 3 parts, and I'm not quite sure if you really want to get, like, 1 full hour and a half, that's really that's
Thank you.